Hi, I'm Alexandra, and I'm reviving an old laptop to be something usable in our modern world. Now, I wanted to keep the old aesthetic, but also I wanted to expand some of the functionality and capabilities. In the last video, we opened up the defective power brick and found some resistors are missing. I did actually add in the video that my original assumptions that the resistors that were missing was the problem was in fact incorrect.
Resistance is futile.
But at the time of filming, I already knew that the power brick will not be used. Today we're going to have a look at the insides of our laptop. We're finally going to take it apart and going to see what we have to deal with. Join me as we explore new territories and find out what exactly we have on hand.
From the outside, it doesn't look hard to compress these hours worth of struggle and failed attempts into a couple of seconds on screen. Simply put, here we undo some screws, being extremely careful not to damage or break the brittle plastic any more than it already is. With all new things, specifically aged plastic, the first assumption is that it will simply disintegrate when you touch it. Luckily, this plastic is from the 90s and it is tough. After some time, the hamster wheel in my mind finally starts spinning, and I get to realize that maybe using our old, trusty, useless plastic card may assist in prying the sides open. One comment here: it is quite a tight fit, but eventually we will get to success and release the insides. The first thing to notice, like in our previous video, instead of actually watching the video of an expert who has successfully done this before, we just go ahead with our primitive banana fingers and have a go at it. Upon opening, we see the keyboard is securely fastened by a couple of T9 screws, you know, the 6-point star thingy, and we proceed to loosen them all to finally lift the keyboard from the chassis. I am not sure what exactly is happening in my head here, and I missed the point of being intentional and careful and mindful during this assembly. So let's play a game. Can you tell me in the comments about all the mistakes I'm making? The first one was breaking the sliding connection of the keyboard. Whoops! That piece of plastic is not supposed to come off by itself. After a bit too much struggle, we can finally get the hard drive loose. As you can see, this hard drive still used the standard IDE/ATA of the time. On the bottom of this hard drive, it looks like it has a pretty nice heatsink, but it's just a plastic spacer. At the end of this flexible ribbon is a simple speaker module and LED. And finally, to the right, we have our 3.5-inch floppy disk reader, also referred to as a stiffy. Now, I'm not nearly close to have reached the advanced achievement of aging, so I'm quite uncertain where it comes from. Basically, for my younger viewers, it was a USB port that works with a specific type of USB known as a stiffy disk. If you want to learn more about the technology of ancient Egypt, you're welcome to check out any one of these videos. This clip is from the Computer History Museum.
This little guy. This is where the computer program is stored. Those floppy disks are the most convenient way of storing or transferring information for a computer.
On this?
Now we're getting to the final ingredient of this laptop, the actual computer part. I am always so intrigued with the lines and traces on older computer boards, mainly because it's neater and more compact than older hand-wired technology, and yet is still big enough and relatively simple enough to actually follow along with the naked eye. Unlike most modern PCBs that are super compact, efficient, and may even have many hidden layers sandwiched in between. Sadly, we barely got inside and I'll already see a lot of oxidation. Instead of letting you guess, I'm going to tell you that our battery is a bit under the weather, and the smell is reminiscent of why people wore lab coats with gas masks. These batteries were made with nickel and cadmium. I wouldn't exactly volunteer to put battery sugar of any kind in my coffee. Not to give you too much of a hint of spotting the errors I made, but as you can see here, this wonderful error here is called a user error. This is obviously a flaw in design, and I attribute this damage to a manufacturer's neglect and oversight and not planning for these things to last. Come on guys, be better. This specific laptop has 3 double-sided circuits connected with spacers in between. They are also connected with a special coupling connector. This is probably the best way to visualize the previously discussed multi-layer PCBs. But let's put that all apart. All signals eventually intersect at the sorting center, or in our case, the CPU, the central processing unit. We have here the perfect version of an Intel i386. This was all the rage back in the day. Think of it as the i9 14900K of the early 90s. Think of it as revolutionary. The actual plastic casing shows years of use and decades of neglect. But this is no match for a can-do attitude and modern adhesives. After a thorough scrub, I mixed the epoxy glue well. It is supposedly clear epoxy, but it kind of ages into a yellowish tint. Not exactly what I wanted, but it does make it look like this repair was done ages ago. I do want to keep the cracks and the breaks as obvious as possible. I want it to look weathered at the end of the day. The repairs went splendidly. Now I just have to set it aside to dry. There are many considerations when choosing a new screen. Firstly, you have budget, and you have what will fit, what will work, and what will look nice. Now, I haven't spent a lot of time discussing what the new internals of this laptop will be, or why I chose it. But what I can tell you so far is I have a Samsung A7 tablet lying around, and a simple financial hack I can teach you right now is when you use what you've got, you're probably going to save a lot. So, if you already have a tablet, the screen is probably the best one you'll get for free. I think this one goes up to 4K, but for our purpose, we do not really need 4K. This tablet screen is slightly oversized in the width and slightly undersized in the height. Added that the original 1990 tray was for the screen to be the perfect 4:3 aspect ratio. None of this widescreen, ultra-wide, mega uber quantum wide stuff. So, with adding the tablet, the obvious assumption is that I'll just use it in desktop mode. But this is where the spoiler comes in, because you are wrong. My plan is way more thorough than that. But we will get to that in the next episode. Right now, the screen does not fit. Despite all the chaos and destruction I rained onto the plastic cover, my hands and my primitive tools were just not enough. So I'm taking it to a CNC shop. It was at this point that I realized my previously mentioned financial act was probably misguided, because if you had to take this to a CNC shop, you would realize it would have in fact be cheaper to sell the tablet and just buy the actual screen that will fit your machine. But here I am to reinvent the road, so I do not have to change my offbeat wheels. Now that the tablet will fit with absolute precision, it is time to move on to the next step. The keyboard. How will we get it to work? What software or specialized programming is required to get everything back together in time for our first university class, which is just around the corner.
Given this point of suspense and mystery, I'm gonna sign off right here. In the next episode, I'm taking on perhaps the most unnecessarily challenging aspect of the whole build, the keyboard. And it is a 30-something-year-old keyboard. It is a slim design, it is not mechanical, yet it is vital for me to keep it, to keep the overall flow and aesthetic going. We'll also be looking at some of the electronics and software that can help us to interface with the keyboard and the tablet. And not only that, we also want to keep it looking relevant to the time. So I'm looking forward to sharing the rest of the journey with you. The like and subscribe buttons are there if you want to be on board with the next episode. I've been Alexandra, and I turn old technology into something new and usable in our modern world, mostly whilst maintaining the original aesthetic and function.